Alright, here we go, boys and girls. Don't know how this is going to work, don't know how much energy I'm going to have to finish all these, but here's some final review videos for the standards and example problems I put on OneNote in this, starting off in the IF. You should be looking at the final right next to this on OneNote. I'm going to be referencing this all the time and showing this up on the screen. And we're going to be going through these problems, a quick video to explain these problems. A quick disclaimer though, remember, and I should put another different color up here, just to remember, a quick disclaimer, this is not all-inclusive. You could see other concepts that are not included on this video or these series of videos, so it's upon you to go back and study everything we've learned throughout the entire year. The spring final is cumulative. Okay, so the first question on interpreting functions is being able to figure out end behavior. Now, end behavior is always based on the leading highest order term. We like to call that the leading coefficient if it's written in standard form, which means in according to degree in descending order, as this one is. So it's very simple. Remember, we first look at the sign, positive or negative, of the first term. This one is negative, so the right end of a polynomial function is going to be end behavior down towards negative infinity. And then we look at the exponent. If the exponent is odd, then the left end is opposite the right end. So that's for this question. Here are some other ones just to cover up all four possibilities. This one's positive, so that's up. This one's even, so the left end matches. This one's negative, so that's down. This one's even, so the left end matches. This one's positive, so right end up. Exponent's odd, left end is opposite. And this is just like our example up here. We've got right end down because that's negative and this is odd. So we go like that. Okay, right into the next concept. I'll try to put 3 or 4 questions on each one of those videos. That way I don't waste too much space, but I can't make these videos too big. Anyway, we're looking at answering all these questions about a polynomial function based on stuff we did last semester. So there's the graph we're talking about. Okay, the right end is up, so the A is positive. The degree, remember we're counting the number of increasing or decreasing intervals. So 1, 2, 3, 4, 5. So you got increasing, increasing, increasing for 3 increasing intervals and 2 decreasing intervals. So the degree must be 5. So degree 5. Let's see, the number and type of extrema. We've got an odd function here. So we've got 1, 2, 3, 4 relative extrema. This one's a relative max, relative min, relative max, relative min. Okay, so labeled is what you would do on the test. How about the total number of roots? Remember, the total number of roots is going to be the same as the degree. It's a trick question. So the total roots is 5. Now how about the nature of the roots? We've got 1, 2, 3 distinct reals where they meet the x-axis. So 3 distinct reals. But we have to get up to 5, and we have to have an imaginary pair. And I taught you guys, remember, it's this saddle point right here where it kind of looks like there's an imaginary x-axis where it would hit right there. So you'd say 2 imaginary, or you could say that is 1 imaginary pair for a total of 5. Okay, so we got 3 minutes on this video so far. Here's another example. Let's answer the same questions for this one over here. Let's see, A is positive again. Let's see, what's the degree of this one? How many increasing and decreasing intervals do we have? 1, 2, 3, 4. So the degree is 4. Let's see, you'd have a absolute minimum right there. You have a relative max and a relative min. Let's see, how many total roots are there? 4. How many, what the nature of the roots? We've got 1, 2, 3, 4 distinct reals. So 4 adds up to that one right there. And then lastly, we have no other imaginaries, so that's what we'd have to do for that one. Okay, that's it for this video.